Hello and welcome to this tutorial on how to scan Docker images and our file system looking for CVE, so common vulnerabilities and exposures, with the Trivy, which is a command line utility that is very useful when we want to check all sorts of package management systems. So for example, on Linux, you could check apt packages on Debian and Ubuntu, or YAM packages on CentOS and Fedora, or in any kind of programming language for the main programming languages. For example, Node.js package.json files, pip dependencies in Python, Go modules and Go dependencies, and so on and so forth. All right, so today we're going to see how we can install this command, how can we scan Docker images, and how can we scan all sorts of dependencies. All right, so if you check this website, which is from Aqua Security, the company behind Trivy, you can see that you can install this package in many different ways. In my scenario, that I'm on a Linux Ubuntu laptop, I decided to follow their details about adding a Debian repository to my apt list, and then basically do the usual apt-get install Trivy. Okay, so let's double check Trivy, and here we can see that we have our version 0.20.1. It's kind of the latest version based on the timestamp when we're recording this video. Okay, so let's say we have a Docker image that is based on a Debian image, and then we're doing something with this, and we want to check, we want to scan this image for vulnerabilities. Now we're gonna see a few different things, like we're gonna scan a very old image for the time when we're recording these videos. So this Wheezy Slim is more than 2 years old. Here you have the timestamp when the image was released. Then we're gonna check, we're gonna scan the Stretch Slim image, which is the current long-time support image for Debian. And then we're gonna scan our Bullseye Slim image, which is the current version of Debian, the most up-to-date. And finally, we're gonna scan a Docker image based on Alpine Linux, which is known for being very slim. Hopefully we're gonna see something also in terms of vulnerabilities. Okay, so let's go ahead and run these Makefile targets. For whoever is not familiar with Makefiles, you have the command make that is reading files called Makefile, and there are targets that are defined with a name or label, and are basically very similar to the idea of a function. So if you type make Trivy check Docker outdated Debian image, you're gonna run the commands that are inside this target. Okay, so Makefiles are convenient to wrap together multiple commands, so we're gonna use them to show different scenarios. Okay, so let's start by invoking make Trivy check Docker updated Debian image, and this is gonna invoke this command from Trivy. So we want to filter our vulnerabilities by high and critical. This is the name of the Docker image we want to scan. The fact that we want to scan a Docker image is given by the fact that we are specifying image as a subcommand for Trivy. Then we also want to exit with a code that is not 0 if we find vulnerabilities. So basically this is helpful if we want to set up a CI/CD pipeline where, for example, we're not deploying to production if we find some sort of vulnerabilities. So we exit with a code that is non-zero and we block the pipeline. Okay, so now let's run this and see what happens. Okay, as you can see, this is a quite old image and we can find lots of vulnerabilities. If we start from the top, you see that there are high and critical vulnerabilities. You can check the details about these CVE vulnerabilities. These are well-known vulnerabilities and you can follow these links, but also to get an overview, here at the top of the Makefile I provided a few links. So this is the official website, this is the old official website, and at the moment there's kind of transition from the old website to the new website. And this is the Wikipedia page where you can read about common vulnerabilities and exposures. Okay, so let's go back to our command. Here you can see there are lots of critical and high vulnerabilities. So this is a good incentive to upgrade our images to try to stay on track with the latest versions and minimize the number of vulnerabilities. Here you can see the Makefile target exited with an error code. So suppose you have this target inside a CI pipeline, the pipeline would block at this point and we're able to prevent vulnerabilities from reaching, for example, a production deployment. Okay, so we checked this very old Debian image from the time of recording, so 2 years old. And now we can check the long-term support image. We can scan it and see what we can find. Okay, even in our long-term support image, we can see there are lots of vulnerabilities. And this may be not a good news. As usual, in this summary table, you have details about how to find more information about vulnerabilities. So I encourage you to, click on these links and read about the vulnerabilities. All right, so we checked a very old Debian image. We checked the current long-term support image from Debian. And now we can check the current stable image from Debian. And at the time of recording, this is Bullseye Slim. So let's copy this. Let's invoke make this Trivy check docker current Debian stable image. And you can see that the scenario is much better now, but still there's a couple of critical vulnerabilities. And this is the latest stable version of Debian. Now, let's assume that we are happy with this vulnerability because we want to stick with the Debian image for any kind of reason, and we decide to take the risk and deploy to production even if we have this critical vulnerability. So this is defined here with an ID. With that, for convenience, I copy pasted also on the source code, and we can add this to our .trivy ignore file. So here in the current directory we have the Makefile we went through until now, and also this Trivy ignore file. So we add it here, we go back to our Makefile, and then we can ignore this vulnerability from the scan. Let's see if now it's a bit better. Bear in mind the Makefile exit with an error code, so the hypothetical pipeline is blocking at this time, but we decide to take the risk and run again the scan. And now, because we ignored some vulnerabilities. Our scan is successful, so we exit with a zero code, and our pipeline can go on to the next stage, for example, deploying our Docker image as a container in a production environment. You can also change the severity levels. So, for example, you can decide to ignore some levels and not others. And let's say that, let's go back to our original version and let's remove this command line parameter, and let's say that we are on the latest Debian version, and for some reason we cannot change distribution. For example, we cannot use an Alpine Linux Docker image, and also we want to ignore unfixed common vulnerabilities. So, for example, let's say this vulnerability doesn't have a fix yet, so we want to exclude these vulnerabilities from our scan. We can also do this with passing this command line parameter, and this way we are able to basically ignore any vulnerability that doesn't have a fix yet. So basically we know that everyone is exposed to this vulnerability if they use standard tools like apt to manage packages in Debian. Okay, so we've seen that even the latest version of Debian could have some vulnerabilities. Usually they're very low in numbers, but still there are some vulnerabilities. So let's see if at the time of recording the latest version of Alpine has some vulnerabilities. So here you can see there's the usual command with an exit code set to 1, the severity level set to filter only vulnerabilities labeled as high and critical, and then at the time of recording this is the latest version of Alpine Linux from August 27th, 2021. Okay, let's go on. Let's go ahead and see how it goes. Okay, so we know that this last version of Docker Alpine doesn't include any vulnerability. So we can, for example, assess and decide if we want to move from a Docker image to an Alpine Linux image, or if we're happy with Docker, for example, for stability reasons or for well-known problems with Alpine Linux and the C libraries underneath. We may want to stick to Debian images, and then we may want to, ignore some vulnerabilities in case we are happy with taking these risks. Okay, so let's say we are software developers. We develop in our preferred language. It could be Node.js, C#, Java, Go, Python, any kind of language. And all these languages provide a way to bundle applications with packages and dependencies. So we can specify these dependencies in our dependency files, and maybe some of these dependencies contain vulnerabilities. Now, if we we could start with an application written in Node.js. Here you have an example of application written in Node.js. It's a very simple application. It's just an HTTP server exposing a URL that is replying with hello. This is a well-known dependency in the Node.js programming language, and we decided to go with this Express version 3.21.2 as it is actually quite old compared to the current time of recording this video. So this dependency is from 2015, so 6 years from now. At the moment we are on 4.17.1, so we expect to see some vulnerabilities. So let's go ahead and run this to see what we could find out. Okay, and as you can see, there are lots of vulnerabilities because the package is very old. And so one solution could be, for example, to upgrade our version and hopefully minimize the number of vulnerabilities, or ignore, as we said before, some of these vulnerabilities because for some reason we need to stick with this version because maybe we have another dependency that doesn't work with the latest version, and at the moment we want to decide to take this risk. So we can, tweak this command and be able to ignore something that we decide to ignore on purpose. Let's go on with a Python example. Now, Python has a package manager called pip, and by default for the user developing applications, pip installs packages at this path. At the time of recording, Python 3.8 is the standard version for even an Ubuntu distribution. And in here, we have lots of dependencies that are treated as global by Python. So we can scan our file system. And by the way, sorry, this scan with Node was based on the file system subcommand. And whereas before we were using the image subcommand for Docker images. All right, so let's go ahead and run this command and see what's vulnerable from my current dependencies installed in my laptop. Here you can see, for example, we are installing a version for the Flask dependency just for documentation purposes, and here we invoke the Trivy command on our file system, pointing at this location in our file system. And as you can see, there are quite a few vulnerabilities. And again, assuming that in our Python application, we may want to ignore some of them, we know that we can do this with a few different techniques and strategies we've seen in previous examples. All right, so as a final example, let's check a Go dependencies and see if there are some vulnerabilities. Now, Go by default sets what is called a Go path to home/Go, and in here we're storing lots of dependencies that we are using in different projects, right? So it's basically like the Maven local repository for Java. Here you can see we have quite a few vulnerabilities. This is because we were forced to use outdated versions of packages in some projects, so we knew we had some vulnerabilities. However, another way to ignore vulnerabilities in case we decide to take the risk is by skipping some files. So in Go, the way you specify dependencies is via a Go modules. So there's this file called go_sum that we could decide to ignore to basically skip some vulnerabilities and pretend we take the risk. So here we have this dependency with this sum file, and we can skip it. And as you can see here, this file that we are going to skip with this parameter from the command has this vulnerability, and hopefully after running this command again, we won't see this vulnerability in the output. So let's go ahead and run again the same command. All right, and as you can see here, we're not seeing the same .sum file here, so we are basically ignoring all the vulnerabilities coming from this file. Here you can see, again, we're now seeing the same vulnerabilities. All right, I guess that's it for today. You can find this source code at this link on GitHub. Hope you enjoyed this journey on how to use Trivy to scan for vulnerabilities in your Docker images or source code projects in various languages. Please do check the official documentation about CVEs. Happy DevOps coding to everyone. Actually, happy DevSecops coding to everyone. And I will catch you on the next one.